What is the blockchain, and why use the blockchain? First, let's start with a more formal definition of the blockchain and unpack it. Formally, the blockchain is a distributed and decentralized ledger that stores data such as transactions between individuals, and that ledger is publicly shared across all the nodes of its network. The storage itself consists of multiple blocks of data, chained together like the links of a physical chain. So how are these links created? Well, every block is given a unique value that looks like a random string of characters. We call this value the hash, since it's generated from a hash function that creates a unique output for every unique input that it receives. The hash is generated based on the unique data that we want the block to store. This data within the block can be anything, a string like foo, for example, or an array of numbers, or more relevantly, a list of transactions from one individual to another one. The unique hash for the block is generated not only from the data we want to store, but also more metadata about the block, such as when it was created and its position in the chain. There's also one more very crucial data point used to generate the hash of a new block. The unique hash of the last block is also used as part of the input that the new block uses to generate its hash. This means that the last block is an integral part of creating the new block's hash value. In addition, the block itself will now have a reference to the last block's hash value as part of its public data. Links from block to block are created because each new block makes a reference to the last block's value. This reference to the last block's value links the last block to the new one. And as more blocks are created, eventually we have this chain of blocks, creating the blockchain. Okay, so that's a high-level overview of the blockchain. There's still a few concepts from the original definition that we have yet to explore, so let's unpack those. First off, we have this idea of a ledger. A ledger is a record-keeping book that records all the transactions of an organization. It records contracts, payments, movements of assets, etc., so that the organization can track its economic history. As a ledger, the blockchain serves the purpose of storing transactional data. So the blockchain is a ledger. And as we defined earlier, it's in fact a distributed ledger. So what makes it distributed? A blockchain ledger is distributed because the ledger itself is shared with everyone using the blockchain network. In this network, multiple nodes, or rather multiple individuals, through computers connect to the core blockchain network. By connecting to the blockchain network, they each get a copy of the complete blockchain ledger that has recorded the entire history of data that is stored in the blockchain. Now that everyone has a copy of the blockchain ledger, they will get updates every time someone changes their individual blockchain as it's sent through the network. This idea of the blockchain ledger being distributed touches on the idea of the blockchain also being decentralized. Since everyone has a copy of the updating ledger, there is not one central organization with the responsibility of updating and maintaining that ledger. Let's discuss this idea of decentralization further by contrasting the centralized and decentralized models. In the centralized model, a bank holds the ledger itself and records the transactions of everyone's financial accounts. It holds all the data for the organization. So the bank, as the central organization, has all the responsibility and yet all of the power at the same time. So some might see this as a potential negative of a centralized model. Since a ledger is controlled by a single entity, they have complete authority, whether that means invalidating transactions or enacting fines that you might find unfair. However, there are some positives to the centralized model, since the bank can perhaps give you incentives to join their system, or they can give you reward points for using your credit card and insurance policies in case your items get lost or damaged. Still, in this system, you completely trust that central entity in order to record all of your transactions. On the other hand, the decentralized model is trustless, which counterintuitively means you trust the decentralized system itself, and in a way, you can trust it even more than a central organization. Everyone has equal power and access to the history of transactions in the decentralized model. And furthermore, everyone has the responsibility of recording these transactions. So the system is fair and transparent, and the record of transactions is not kept behind closed doors. You don't trust one organization to manage the data. Rather, you trust the system itself, since you don't have to trust anyone. Finally, let's continue answering this question. We've already started answering it a little bit, but let's ask again, why use the blockchain? So, as a distributed and decentralized system, it's trustless, in the sense that you don't place all the power of recording transactions within one organization. Now, this also means we eliminate the necessity for third-party intermediaries and middlemen to handle our transactions that could enact fees for their services. In the blockchain network, two nodes can trade with each other directly without having to rely on a bank or an accountant to officially document the transaction. Given the nature of the decentralized system, the blockchain is also highly secure. There is not one central point of failure. A hacker that is trying to take down a bank needs to only take down that one bank in a centralized system. In the blockchain, the attacker needs to take over thousands, if not millions, of nodes and computers to hijack the network. This also makes the system very dependable. With all the nodes of the blockchain network recording transactions, you can trust that your data is present, even if your own connected node temporarily goes down. Overall, we now have a better grasp of the blockchain and its definition. We understand what it means when we define that the blockchain is a distributed and decentralized ledger that stores data, such as transactions between individuals. And we know the great benefits of that ledger being publicly shared across all the nodes of its network. Next up, let's explore the main ways that blockchain technology is being used today in order to revolutionize the world. We now have an understanding of what the blockchain is: a decentralized and distributed ledger that is publicly shared across the nodes of its network. Now let's go into the blockchain in practice and discover the use cases for blockchain technology. The first use case you will often hear people bring up is a cryptocurrency. Blockchain technology and cryptocurrencies so frequently appear in the same sentence that the concepts have almost become synonymous in tech culture. So cryptocurrencies do leverage the blockchain, but a cryptocurrency is its own technology that only has the blockchain as one piece in its puzzle. A cryptocurrency itself is a digital medium of exchange. It has three main aspects. First, indeed a secure blockchain. Then it has cryptocurrency wallets. And then it also has the concept of mining. For the first aspect, the cryptocurrency leverages the blockchain. It does so in order to keep a public database of transactions that everyone has access to. One question, though, is if everyone has public access to this database, couldn't someone modify the data in order to manipulate the system and transfer more currency to themselves? Well, to prevent this problem, as part of the solution, a cryptocurrency uses cryptography to add a layer of security to the blockchain. With cryptography, the blockchain uses a technique of using algorithms to obscure data into hidden, or in other words, cryptic messages, which gives the blockchain the ability to generate digital signatures for individuals in the network. So these digital signatures are like unique handwritten signatures, but with far more inherent security, as it solves the problem of impersonation and tampering. So in practice, each individual who wants to record a transaction in the blockchain must stamp the transactional data with the unique digital signature. So how do these signatures work? Well, each individual signature is based on two keys, a private key and a public key. These keys are a string of numbers. So one key is a private key that only the one individual has access to. The other key is a public key that everyone can see in order to identify the individual. With these keys then, the user has the ability to sign data, such as transactional data. The individual creates a signature that is an encrypted hash value. The hash value is generated by a combination of the data and the private key of the individual. So since the value of the hash is based on the original data, Any change to that original data, such as just changing one character value, will generate a new hash signature. And now that the data has a signature, anyone can use the same derived public key of the individual to verify that signature. The public key is used to decrypt that signature and then read the original data behind it. So, in the event that this decrypted data does not match the original data presented by the transaction, we know that one of two events have happened. Well, the original data was tampered or altered corruptly, since the data that was signed does not match what was decrypted from the signature using the signer's public key. Or, on the other hand, the signature was generated with a private key that does not correspond with the public key that is presented by the person who is doing the transaction. So overall, the system with the private key and public key pair to generate signatures on data adds a highly secure system of integrity as well as authentication to the blockchain-based cryptocurrency. This brings us to the second aspect of cryptocurrencies, wallets. Wallets are objects that store the private key and the public key of an individual in the network. Like a physical wallet, they can also help you track how much cryptocurrency is entitled to you. Your public key is used as an address for your wallet, and that is what other individuals use to send cryptocurrency to you. And by utilizing the stored private key, the wallets are used to help generate the signatures that sign transactional data. For our final and third aspect of cryptocurrencies, we have mining, which we'll explore in more detail next.